My main project for this past winter has been the RetroPanel. It's a drive bay expansion for my retro computers. While it has a few standout features such as a megahertz display and a turbo switch, it does have quite a lot more features than that. However, having already gone through all that in the introductional video to the RetroPanel, I'm instead going to focus entirely on the process of building a RetroPanel in this video. The first thing you need to know about building a RetroPanel is that it is not intended to be a single thing. It is just a collection of various functionality. It can be a dumb panel for just plugging in your switches and LEDs and so forth. You can skip installing the feature that you don't need, such as the smart power switch. You don't really need the RS232 functionality. So if you don't want it, I'm not forcing you to do it. So let's tack one together. The RetroPanel is built using these 5 PCBs. The side panels are the same. You just need 2 of them. This is the main PCB that will hold most of the components. A cosmetic faceplate for the front. The front panel holds all of the switches and LEDs. We need 2 of these side panels. They're identical. But let's just get started on putting some components onto the board. And we'll start with something easy, resistors. Most of the resistor values should be fairly standard, and you should find them within the 30 value resistor packs sold just about everywhere. The exception being the 27K and the 33K. Both of these are part of the smart power switch circuit, so if you don't need that, you don't need them. Additionally, as there are a certain voltage level coming from the motherboard to light up an LED, a modern LED might be extremely bright. Where you encounter the 470 ohm resistors on the board, these were selected as a fail-safe value for most common LEDs, but if you require a specific and in particular modern LED to be used, then you need to adjust this value. Before continuing, you need to figure out whether your 7-segment display is a common anode or the common cathode variety. Only the common anode variety can be used with a diagnostic card. First things first though, we need to set a few jumpers according to what components we are going to install on the board. This is just to ensure that we have easy access to actually set them. The pin numbers are designated via the numbers. You can tell the difference because the pin number 1 is a square while the other 2 are round. The first 3 here set that the power LED on the front is controlled by the Arduino. The one below it links to whether the Arduino should be connected to the turbo switch signal or the turbo LED signal. Last jumper is for the 7-segment display. The setting I'm using is the lower one, indicated that I'm using a common anode type display. Well, let's just get back to actually installing some of those resistors. Feel free to skip ahead or just listen to the music. Picked up this handy little tool for shaping resistors and so forth on eBay a while back. It's a real pleasure to use when attempting to shape everything and getting all of them uniform. There's a single 1N5819 Schottky diode on the board. It's there to keep your Arduino from attempting to, well, power your PC. It wouldn't work, it'll only burn out the Arduino, so don't do that. The diode will only work as expected if it's going in the correct way, so ensure that you match the silver stripe to the indication on the board. To socket or not to socket, that is the question. Well, if you're cheap, skip it. If you hate the soldering stuff, install them. Whatever you do, just ensure that you install them with the pin 1 indication, that's the indent, in the correct position. Just follow the silk screen. And now we come to the hardest part to find. It's the floppy power connector, the one that you always expect to find everywhere, but apparently almost nobody sells it. I tried looking for bird connector, which is the name of the other part of it. No joy. Finally I found one on AliExpress. Apparently it's called a JVC Mini 4-pin connector. So let's add some small value capacitors. I like these yellow ones. Apparently they're called monolithic capacitors. I couldn't really tell you the difference between these and the ceramic ones. I just like the look of them. First, we need to say a few words about these things. Depending on where you got your MAX232 chip, you either got the cheap one or you got the more advanced chip. Going back to the cheap ones, you need different capacitors. You need electrolytic ones. For the MAX232A, you're in luck. We just install these 100 nanofarad monolithic capacitors and call it a day. These are also used in the other positions on the board where there isn't a value specified. The only exception is the one you're left with. It's the 1000 nanofarad. If you have one of these handy 30 value kits, it should be there. It's marked 105. The same thing is marked on the capacitor itself. And so we get to the point where you get to play with transistors. And so we need to remember back to the point where you set all the jumpers. At that point we had decided what kind of 7-segment display we were installing. In this case the common anode version. A side effect of that is that we need to substitute the transistor value and install it backwards. You can get very expensive capacitors that match the leg spacing on the board, but I found that I could just as easily buy these super cheap ones and just slightly bend the legs apart myself. Pushing them in might make it twist a little bit, but that's okay. If installing a common anode display, we can install an IDC header for a diagnostic card. Also, we can add one for the RS-232 port. Dual row pin headers are the cheaper options, but you don't get cable keying. Let's add some pin headers for the Arduino Pro Micro. There are a double set of pin headers in one position. This is because Arduino Pro Micros tend to come in either a more narrow version or a wider version. You either need to install a single set of pin headers in the correct position according to what you have, or just do what I did and add some female pin headers to the Arduino itself. While we're at it, let's just throw in some pin headers for the I2C connections as well. The RetroPanel was also a handy place to put a small passive speaker that can be connected as the PC speaker or to something like the noisemaker. To ensure that it's a passive one, just test it with a battery. It should sound like this. For the pin headers used with the various signals from the motherboard, I wanted to use a different color for the switches and the LEDs themselves. They never go in straight, so just solder in a single pin. Look at what you got, then reheat and adjust the position until you're satisfied with it. I am putting in a standby LED. It's just the regular 5mm one. I just picked a yellow one at random. The longer leg goes in the round hole, at least the pad is round. Personally, I can never get the LEDs to stay flush against the board, at least not the first time I solder it. So later you'll just see me reheating it and then finally pushing it flush before soldering in the rest. Of course, if you wanted the standby LED on the front of the case, you could always solder in a set of wires to one of the other LEDs on the front. In particular, the hard disk drive LED isn't explicitly used by any of the other functionality, so it's a good candidate. So this is the front panel PCB. It'll mount on the main PCB at an angle. The way we're doing it is using these right angle pin headers, pretty standard stuff. Just need to get the angle perfectly right. Note that we are soldering the pins in so that they're at the front of the PCB and not the back. To get them to sit right, I just solder a couple of pins, then I'm reheating it to ensure that it stays flush against the board. Two types of 6-pin switches are used, both a latching and a non-latching variant. There are similar switches. They all need to have a black base. If it's a different color at the bottom, they have a different pinout and you can't use them. This is the momentary one, or the non-latching. It's used for the reset switch as well as the tool button. The latching one has a white top. It is used for the power button if you don't want the smart power switch, as well as the turbo button. So for my build, that's 3 momentary switches and 1 latching. Note that this circuit won't work if you're installing them upside down. Looking at the underside, you can see a little square hole towards the top. That's also the square indicated on the PCB outline. To ensure that I'm getting the alignment correct, I'm also adding these 10mm hex standoffs to each of the corners. Just getting back to installing the switches. Getting the square hole towards the top. Solder in a pin and then readjust as needed. With the switches installed, I'm just going to add the LEDs. I'm just going to pop them into the holes. The long leg goes into the round hole at the top. It's important that you don't solder anything at this point. Just leave them there. The reason for this is that we need to align it to a faceplate. So let's just add that one on top now. To avoid the thing sliding around, I'm putting it in place with some extra hex standoffs. The front panel should now sit flush against the surface when we put it down. Ideally, the LEDs should now have fallen into the holes cut out into the faceplate. Readjust before soldering all the pins. The 7-segment display can be mounted in several ways. Sitting flush with the outside edge of faceplate, it will barely reach into the through-hole pads. The solution I'm using here is to use machined female round pin header pins. So with the faceplate removed again, let's just add them in place. The downside, of course, is that you now have to experience the joys of using round machine pins. When trying on the faceplate, you might find that it doesn't go clear of the 7-segment displays. The reason is that PCB fabrication doesn't always have the cleanest inside edges, so you may need to clean that up with a sharp disposable blade. It may take some blood, sweat and tears, but in the end, you'll get there. Getting back to the main module, we'll just insert the right angle pin headers so that the boards completely slot together. Having soldered in a single pin, I'm going to use one of these side pieces to ensure that the module sits together at a 90-degree angle. Checking both sides. Having soldered the remaining pins, I'm just going to cut off the excess from the bottom. We don't want all that shorting on whatever's below. And finally it's starting to look like something. We're going to work on installing the side panels. First thing we need to take care of is to get rid of all the hex standoffs and all that on the front. With all of those removed, this is what we're left with. To get the vertical alignment of the main PCB correct, we're going to use the same hex standoffs again, but this time we're adding it through the main module. There should be one at each corner. The nut at the bottom should just barely grip onto the screw. The screw shouldn't be poking through it. Having done all the 4 corners, we should be able to put it down and have it rest securely on the nuts alone. The inside edge of the main PCB has a cutout for a M3 nut with 2 of the flat edges inserted into the groove. You can use it to position one of the side panels. To ensure that the panel itself doesn't move, I'm going to insert a screw through it and into the nut. Having done both sides, I'm just going to put the whole thing straight down on the desk. Then gently push on each side so that it completely adjusts itself to the flat surface. With all of the hard parts done, let's get to welding. On all of the corners there should now be some SMD solder pads that should align with each other. To weld the boards together, we'll just heat up and fill one of them with solder, then move on to the one next to it and do the same. After that, let's just heat up and ensure that it all melts into a single blob. Essentially, doing just about everything you've ever been told not to do. When done on that side, turn it over and do the same thing here. Make sure that you get all of the inside edges as well. Remove all the hex standoffs and nuts from the project. And before I lose them, I'm going to return the 10mm hex standoffs to the front panel where we had them earlier. Having an Arduino Pro Micro on the board seems a bit overkill, at least if you're not doing anything more with it than showing 2 values for the turbo switch. So I added the ability to mount a couple of I2C modules. This is the 5V version of the BMP 280. It's a handy little module. Since I wanted the ability to remove it later, I'm adding some female header pins. The important part when installing it is that for the pin out to match, you need to put the hole in the board so that it points toward the right when it's inserted onto the pins. The other common module is this DS3231 real-time clock module. I'm also adding the pin headers as before. There is one big problem though. The module is rather large and heavy, so it will flop around when only situated on these female pin headers. You can build it up so that it sits flush in many ways. If you have the M2.5 hex standoffs, I think those will fit the little holes on the side. Alternatively, if you have a thick double-sided tape, you can build that up in several layers to support it. With the modules out of the way, and we'll also move the main unit away, we're going to look at the cables needed to start the ATX power supply. And the first thing is an ATX to AT power adapter. It's a simple thing. It has these P8 and P9 connectors on one side going to an AT motherboard. The two loose pigtails, the black one and the green one, is shorted together to start an ATX power supply connected to the other end. Though it can be done in other ways, I found these extension cables to be handy so that I could see parts from it. Given that I have one that's already made, I'm using this one instead. The difference is that I've removed the spade connectors and installed these other cable lugs, mostly because those were what I had in my tool chest at the time. The first difference between a standard ATX to AT adapter cable is that mine has the added plus 5 volt standby line, and because it was missing, I just nabbed the purple one out of the extension cable that I had handy. It's usually purple, and it probably should be purple according to the standard, but not all cables are made within a standard. Just at least put it in the right place. The gray cable needs to be split into two so that it goes to both the main board as well as the module. So what I've done is cut it and then use a separate wire going to a third position on the RetroPanel itself. Of course, having these cable lugs in place means that I can just use some separate wire and attach it to the module directly. I couldn't get the correct color for all of them, so I used blue instead of purple. But if you don't look very hard at it, it's the only color that sort of matches in a dark room. Having stripped back some of the insulation from the wire, I'm going to install them from left to right. The holes at the bottom left of the main module. Just pre-tinning the wire. I'm using the black wire as the common ground, going into the first hole. The second wire, showing up as white on the camera, is the power OK signal from the PSU. Its purpose is for the ATX power supply to notify a mainboard that a short has been detected on one of the power rails. Considering the PSU ratings, it's definitely a safety feature. The green wire is the power on signal, It's an input to the ATX power supply, telling it to turn on, which is why we usually use it shorted to the ground wire on ATX to AT conversions. It's still an option to do that here as well, but I've chosen to install the smart switch instead. The final wire to go in is the one that was supposed to be purple. It's the 5 volt standby line. This section of the circuit is always powered up as long as the power supply has power. That is actually the intention behind providing such a signal in the first place. So far I've just been tacking the wires on, which isn't going to hold anything, or at least survive handling. So I'm just turning the board over, holding the wires into place. It's jammed under there. So we'll just touch up some solder and get it stuck in there for real this time. Sitting right next to the cable is the mounting holes that we used temporarily earlier. We can add some hex standoffs to it in order to build us a little bit of strain relief. With the shortest hex standoff I could find in place, the next step is simply to find one of these zip ties and loosely add it around the cables. Yeah, that's sort of hanging around the hex standoff. I'm going to take one of these screws, then put it into the hex standoff. It's definitely on the fiddly side of things, but at least you haven't had the problem of figuring it out in the first place. The idea is to just put the screw in loosely, then hook the zip tie around the screw. Just tighten the zip tie so that it holds the cables without dragging anything out. And now it's starting to look like something. When it's nice and tight, just tighten the screw to hold everything in place. And that's a strain relief. And it's time to get things into the sockets, if you install them, that is. The first one is the Max 232A, using the handy pin straightener. I'm matching the indent on the chip itself to that of the socket. 555 getting the same treatment. Yeah, that's starting to look good. Now we have chips and everything. While we're on the subject of inserting things, let's just do the modules as well. The first one is the Arduino Pro Micro. It has the female header pins, so we're good to go. It should only match one set of header pins, but just make sure that you don't get the offset wrong. BMP 280 module, ensuring that the hole on it is to the right side. And the real-time clock. Ah yes, and so we come to the finishing touches. One of the more annoying parts with working in a dank, dark basement is that LEDs that are lit up easily pick up light from the LED next to it. It won't be much of a problem with the older style colored LEDs that I've used, but still I find that adding a bit of heat shrink to the outer section of the LEDs help with the problem. At least I won't have to take the faceplate off again. Heat shrink with a diameter of 5 mm should work most of the time, but I find that the 6 mm ones are easier to work with. Probably won't win any prizes for the ethical treatment of my soldering iron, but My flamethrower is in the garage somewhere. Here I'm just trying to attach the faceplate again. If you experience issues getting it on, the solution is usually just to take a sharp knife and cut off the excess of the tape on the outside of the module. Now that everything fits, let's just screw the faceplate into place and hope we'll never have to remove it again. The 6-pin switches that we used, usually advertised as 8.5mm by 8.5mm. Alongside those you should find a listing for the caps that go on top of them. Line up the square hole in the bottom of them and just push them onto the switch. They should stay on by themselves, but if you're paranoid about it, you can add a little drop of glue to the inside of it, but a very tiny amount, because that'll get inside the switch pretty fast. If you follow my recommendation of doing what I say instead of what I've shown you, you probably won't need to do this step. I had separated the cables and used these cable lugs instead of, well, soldering in extensions to the wire. My excuse, of course, is that the cables came from the original prototype that I made earlier. But let's be honest, these cable lugs extension things are, well, laziness at this point. The reason I'm showing you is that, well, they show up everywhere in the video. So I'm just sort of matching the colors. They should have been exact matches, but I used what I had. And there we have it. The completed RetroPanel in all its glory. Assuming that the Arduino Pro Micro already has the sketch on it, we should be able to test it out on the workbench. However, if you don't have the sketch on it, I'm going to cover that in a future episode. For now, I'm just going to power it up using a standard USB power supply. If all went well, you should see the boot message on the screen. If all looks like a jumbled mess, that's okay. We just need to change the setting and it'll become readable again. The serial interface has a method of specifying that we're using a common anode display, and that's what I'm doing in the background. Once you've tested it out and you're confident in the results of the build process, you can consider to install it in some sort of system. Considering that we have traces on the bottom of the PCB, I'm just putting it on top of a book to isolate it from the metal underneath. Don't want anything shorting, which is probably why you need to do an extra looking over to ensure that you have nothing that's poking too far out of the PCB. Connecting the PSU to power, we should see that a light lights up to indicate that the standby power has been applied to the board. Just a word of caution when it comes to the AT-PSUs, as well as the conversion cables. The P8 and P9 are two separate cables, but if you don't put the two black ones together when plugging it in, you will probably kill something. But hopefully you won't do anything like that with the RetroPanel or otherwise. It's a new day and my old cutting mat, because today we're playing with superglue. In order to have some way of mounting the drive bay expansion in a computer, we need to have something to screw into. So what I'm doing is that I get one of these nylon M3 nuts. I'm using it to place it into the slots towards the back of the main PCB, remembering to keep a finger under the nut so it doesn't fall through. Adding a screw from the outside ensures that it simply won't fall out. The next task that we're going to do after having screwed it in is to take some super glue. While it's probably not the best glue for this purpose, but it's fast and it's excellent for sticking your fingers to the wrong surfaces. Just taking the little brush here. Now the object is to glue the nut itself to the PCB. Just be careful not to get anything on the screw, because we need to remove that later. Ideally, you should be using something like epoxy on the other side, so that the nut is held firmly against the PCB edges. That should hold it firmly and at least survive some handling, though you probably shouldn't mix too much of the superglue and the epoxy. The epoxy won't harden near it or stick to it. Anyway, I'm just using the superglue, and well, I'm hoping I get away with it. Having given it a few minutes to dry, I'm removing the screws so that at least I have a chance of removing it if there was some glue stuck between the two. And yeah, hopefully this will keep it there. If I were to build another one, I might be tempted to use metal nuts and screws instead, so that I could use the same screws found on other devices, but I like the nylon ones. They give a bit of flexibility to the design. I'm not going to show you installing the device into the case. It's 2 screws, you plug in the cables, and that's that. Mentioned earlier, I skipped all of the bits about installing the firmware onto the Arduino Pro Micro, but that'll have to wait for a future episode. Bye!